Welcome to the deep dive. Today we're really digging into the Cisco 300-815 exam. The key stuff you really need to know for Cisco Unified Communication.
All practical things.
Exactly. And you, the listener, you're here to get that knowledge efficiently. And that's our aim.
Right.
Now, this exam, it throws different things at you, multiple choice, sure, but also drag and drop, maybe even Sims.
So you need that solid base.
Definitely. So our mission, let's say, is to take some typical questions, pull them apart, and get to the core ideas. Basically, a shortcut to understanding what really matters here. Okay.
Sounds good. Let's do it. And what's great about using these exam-style questions is they map directly to, the real problems you face managing these systems day to day.
Good pattern.
So we're not just answer hunting. We're figuring out why these features work the way they do. It builds a much deeper, more useful understanding.
Absolutely.
Yeah.
Okay, let's kick off. Scenario 1, classic headache. A voice engineer tearing their hair out. SIP trunk calls are failing. Yeah. Turns out it's mismatched SIP header formatting between their CUCM and the ITSP provider. Right. Common issue.
So the question is, which feature fixes this? Options are A, SIP normalization scripts,
B, SIP profile mapping, C, root pattern translation, or D, digit strip on the trunk. What's the answer?
Okay, for this one, the answer is A, SIP normalization scripts.
Right, SIP normalization scripts. So why those? What makes them the specific tool for this kind of header mess?
Well, SIP normalization scripts use Lua. It's a scripting language.
Okay.
And that gives you incredibly fine-grained control over manipulating the SEPP messages. Think headers like to, from, contact.
The really crucial ones.
Exactly. You can basically rewrite them to perfectly match whatever the ITSP needs, even if the ITSP has some, let's say, non-standard or really rigid requirements.
So the other options like SIP profiles or route patterns, they're just not flexible enough for that level of detail.
Yeah. Precisely. They handle more general cases. But for really specific custom changes needed for one particular provider, these scripts are the way to go. It really shows how, integration isn't always just about sticking strictly to the standard. Sometimes you need to adapt.
Got it. So it's that deep customization. Key takeaway for you listening. If your ITSP is being picky about SEPP headers, look to SEPP normalization scripts for that precise control.
Exactly. Okay. Scenario 2. This one's about device mobility.
Right.
So a user moves their phone, different building, plugs it in, but it keeps the calling search space from the old location.
Frustrating. So what's the likely cause? A, device mobility is disabled in the device pool. B, wrong device mobility group. C, the phone's IP isn't in a configured device mobility info subnet. Or D, the phone just doesn't support device mobility. My gut feeling is it's something about the system not spotting the move. Maybe the IP address.
You're right on track. The answer is C. The phone's IP address isn't in a configured device mobility info subnet.
Okay, C it is. So let's break that down. Why is that specific IP subnet configuration so vital for device mobility?
Well, CUCM figures out where a phone is based primarily on its IP address.
Makes sense.
So you set up these device mobility info subnets in CUCM. You're essentially telling it, okay, IPs in this range belong to Site A, IPs in that range belong to Site B.
Like a location directory based on IP.
Exactly. So when the phone moves, gets a new IP, CUCM checks, is this new IP in one of my known device mobility subnets? If the answer is no.
Then it doesn't realize the phone moved.
Correct. It doesn't recognize the new location, so it doesn't apply the settings for that location, like the local calling search space. It sticks with what it knew before.
Right, so it's like the address isn't in the system's map. The big lesson here seems to be getting those device mobility info subnets configured accurately is absolutely crucial. Otherwise, the whole feature just breaks.
Absolutely crucial. And it's funny, how often troubleshooting this kind of issue comes back to that basic subnet configuration. It's easy to overlook, but the impact is huge.
Definitely wanted to check early. Okay, let's shift gears. Scenario 3, globalized dial plan. We're talking plus E.164 standard.
Okay.
The challenge is you want this global standard, but you also want users inside the company to still dial local numbers the old way. Just the short number, no country code.
Yeah, user convenience, important.
So which feature lets you do both? Options: A, calling party transformation patterns, B, translation patterns, C, call party transformation patterns, or D, root filters.
For this, you need C, Called party transformation patterns.
Called party transformation pattern. Okay,
Yeah.
the name kind of gives it away.
It just
Transforms the number being called.
Exactly. It works on the dialed number. So a user dials, say, a 7-digit local number.
Familiar easy.
Right. CUCM sees that pattern, matches it with a called party transformation pattern, and before it routes the call, it expands it into the full plus E.164 format.
Ah, so the user sees simple, but the system sees global standard.
Precisely. The user keeps their familiar dialing habits, but behind the scenes, the system gets the standardized number it needs for proper routing, especially across different sites or out to the public network. It balances user experience with system requirements.
That's pretty neat. So, takeaway. Implementing plus E.164, but want to keep local dialing simple, called party transformation patterns are your friend.
Definitely. Okay, next up. Optimizing media flow. We're talking about a CUBE, a Cisco Unified Border Element.
Right.
The goal is to get the actual voice and video streams, the media, flowing directly between the phones or endpoints when possible. We want to avoid routing it through the CUBE unnecessarily. That causes hairpinning, apps latency.
Yeah, inefficient.
So which command on the CUBE does this optimization? Is it A, media flow through, B, media flow around, C, direct media enable, or D, media bypass enable?
Around. Sounds like it's going around the CUBE. I'm thinking B, media flow around.
You got it. B, media flow around is the command.
Okay, so what does media flow around actually do, and how's it different from that other one, media flow through?
Good question. So media flow around basically tells the CUBE, okay, handle the call setup signaling, but once the call is established, let the actual media, the RTP stream,
The voice and video data?
let that flow directly between the endpoints, if possible. Don't force it to come through me.
Ah, okay. And media flow through.
That forces all media to pass through the CUBE, always, even if the endpoints could talk directly.
So media flow around is generally better for performance, less latency, less load on the CUBE.
Generally, yes. If the network path allows for direct media, media flow around reduces latency, saves CUBE processing power, and often leads to better call quality. It's a key command for optimizing how media is handled.
Got it. Like letting traffic take the direct highway instead of forcing everyone through a central checkpoint.
Yeah.
The main point for CUBE configuration. Use media flow around to streamline media paths where you can.
Exactly. Now let's tackle intercluster lookup service, ILS, multi-cluster setup.
Okay, ILS. Complex stuff sometimes.
Right. We have 3 clusters, A, B, and C. Here's the situation. Cluster A can learn patterns from cluster C just fine, but it cannot learn patterns from cluster B.
Okay. ACC, but not B.
But cluster C can learn patterns from both A and B. It seems to be working okay as maybe a central point.
Interesting pattern. So, given that specific failure, what's the first thing we should check? A, is URI dialing enabled on AB? Does the ILS domain name match everywhere? C, is the hub and spoke topology configured correctly? Or D, does the SIP trunk security profile support ILS?
What does your gut say?
With A seeing C but not B and C seeing everyone. It feels like a connection issue specific to A and B within the ILS structure. So I'm leaning towards C, the hub and spoke topology configuration.
It's exactly where you should look first. In a hub and spoke ILS setup, how those relationships are defined is absolutely fundamental.
The connections between them.
Yes. If A can talk to C, maybe C is the hub, but A can't talk to B, maybe B is another spoke, or A is peering to B is broken, while C can talk to both. That pattern strongly points to a problem in how cluster A is specifically connected or configured within that topology relative to B.
Like a specific road between A and B is blocked, but the roads to C are clear.
Good analogy. So the takeaway, for ILS in a multi-cluster setup, especially hub and spoke, getting that topology configuration right is step 1. It's the foundation for everything else.
Makes sense. Get the map right first. Okay, final scenario. MGCP gateway survivability.
Right. SRFT, survivable remote site telephony.
We have an MGCP gateway at a branch set up for SRST. WAN goes down.
The moment of truth.
And the phones connected to that gateway fail to register to the local SRST router. They don't switch over. What's the likely culprit? A, SRST isn't enabled on the ePhone DN. B, MGCP fallback isn't enabled. C, voice register pool is misconfigured. Or D, DNS lookup for CUCM is failing.
What feels like the missing link for the switchover itself?
It sounds like the gateway isn't getting the signal, or isn't allowed, to actually switch to the backup SRST mode when the main connection drops. So I'm going with B, MGCP fallback not enabled.
You nailed it. The answer is B, MGCP fallback not enabled.
Okay, so what is MGCP fallback, and why is it the key here?
MGCP fallback is the specific command, the mechanism that tells an MGCP gateway, hey, if you lose your connection to your primary CUCM over the WAN,
Which just happened in this scenario.
you are now authorized to switch into SRST mode and start acting as a mini-call control for the local phones, registering them to the SRST router also running on you.
It's the trigger for the survivability mode.
It's the explicit instruction to enter that mode. Without MGCP fallback enabled, the gateway knows the WAN is down, but it doesn't have permission, essentially, to switch over and provide that local survivability service. The phones just stay unregistered.
So no fallback command, no fallback service,
Yeah.
complete loss of voice at the branch.
Exactly. It's absolutely critical for ensuring that SRST actually works with MGCP gateways.
Right. So the big lesson, using MGCP gateways with SRST for branch survival. You must enable MGCP fallback. No fallback, no survivability. Absolutely. So here's a final thought for you to consider as you continue learning about this stuff. How does really getting to grips with each of these individual parts help build a more resilient, more efficient communication system overall? What other connections between different features or components might reveal similar important insights if you look closer? Thanks for joining us for this deep dive.